This is Chapter 3, Example 2. In this problem, we're looking at the piston cylinder, which contains 0.0566 meters cubed of saturated water vapor at 3.5 bar. So when we look at this, we have our known, right? We just basically have saturated water in a piston cylinder, right? And we're also going to find various pieces of information here. For one, the temperature. And we're also going to find the mass of the vapor. And that's in our cylinder. So when we're in the mass of our vapor here, if we're looking at, since we're given the pressure and a specific volume, right? If we have what we call a mass of the vapor inside, I'm assuming it is the saturated vapor. We're right here on our curve, somewhere there at a pressure of 3.5. Okay, so we have our cylinder, and we probably don't need a schematic here, but we're just going to draw it anyway. And we have vapor water in here. We're given a pressure of 3.5 bar, and the volume is 0.0566 meters cubed. Okay, so when we're looking for the temperature, there's the independent. We can look up the pressure and find the temperature at that particular pressure. The mass, we need a few pieces of information for that. For example, we know that if we have the volume and we divide it by its mass, we're going to get the specific mass. So if we have the mass times the specific mass, that will give us the volume. And if we're looking at G, we want to know the mass of the vapor, and that's going to be our volume. And it's, we only have saturated vapor, so it's all going to be vapor. So we need to look up some information on the table. So we look at our water saturation table here, and we look at our pressure, which we have 3.5 bar, and here's the temperature. So we just have to look up the temperature, 138.9 degrees Celsius. That is the first thing we need to determine. And then the second thing we need to find is our mass. And we need the saturated specific volume, which we have here at 0.5243 meters cubed over kilograms. To find our mass of our saturated vapor, we're going to take the volume and divide it by the specific volume. And so our specific volume is, and we find the mass to be 0.108 kilograms. I probably should put that here. We find the mass to be 0.108 kilograms. And that is our problem.